Okay, so what questions do you guys have for me?
What percentage is it for now?
Basically 7 through 9.
7.3, right?
Can you help with the question from?
That's Gentry. Gentry, you still remember your question. Go ahead, Ethan.
From 8.1 to 33. It wasn't on the homework, but I.
8.133.
Yeah. Really, I'm curious about.
8.133. Putting it together, playing roulette. The game of roulette wheel consists of 38 slots, 0 through 36. See the photo, play the game when the ball's spun. All right. The number of balls falls and you win $35, otherwise you lose. So construct the probability distribution for the random variable x, winnings of each spin. Okay? So, that's definitely a nice complicated one. Okay, is this... All right, so with roulette, you can get, so you got x and then you got probability of x, right? So we're doing a probability distribution. Okay, what's your sample space for roulette? Okay, so we got to be a little bit careful because they have a 0, 0, and they have a 0. Those are two different numbers. And then 1 through 36. 1, 2, oops, 2, 3, etc. The rest of them are okay. Oops, 36. Okay. Now your probability of any number is going to be what? 1 out of 38. Okay. So that's going to be the same probability because it's got equal probability for all of them. Okay? All right. So there's your probability distribution right there. That table. So that's part A. Part B, determine the mean and the standard deviation. So what would be the mean? How would you figure out your mean? And that's, what's another name for your mean? What's another name? Well, you don't like to use the A word, by the way. X bar, okay, what's another one? What's another one? Not p hat for this one. This is not a proportion. Begins with an E, it's got 2 words. Expected value. How do we find the expected value?
Added up divided by.
Nope, that's the mean. Ethan asked a good question. You can stump you all.
How can
You guys forgot that one already? Oh, are we recording? Oh, we're not sharing. There we go. Now we're sharing. Now you can see what I typed in there.
Wait, can you find the expected value if it's discrete?
Mm-hmm. Yes, especially if it's discrete. Yeah. In fact, if it's discrete, that's what we refer to it as the expected value. You guys already forgot? What's the formula for the expected value? Somebody look it up on their formula sheet. Sum of x times the probability of x, right? So all I got to do is I got to find the product of all these. Okay, so if I take x times the probability of x, hopefully that's still going to be 0. Yeah, it is. Copy that down. And now I simply find the mean, which is the sum of that column there. $17.52. So if you got 38 numbers, you'd expect it to be right in the middle, wouldn't you? If they're all equally likely, yeah. Okay.
Okay, so I guess I'm trying to get the answer key. The answer key, I couldn't figure it out, so I went to the answer to see it. And it's
Oh, wait a second.
Did you do the sum of x first?
Well, let's see. Construct the probability distribution of the random value. Determine the mean of the standard deviation. Render results. Okay, actually, I'm looking at this wrong. This is I answered a different question. I answered the question, if you just spun it, what would you get? But there's also an important piece. If the number falls on it and matches your number, you win $35. Otherwise, you lose.
the probability.
So if we add that in there, so now what's your x?
X is 35, probability is 20.
So the probability, so you're going to win $35, or you're going to lose $1, -1. Okay? What's the probability you win? 1 out of 38. What's the probability you lose? 37 out of 38, right? That's better. This is better. So I answered a different question. I didn't read it closely. Okay? You're still going to do the product, which is x times p of x, and copy that down. And then you're still going to find the sum. And so what it's going to tell you is you'll lose a nickel for every time you bet.
So can you go back on those formulas for a second? What's the first one?
This one here, 1 out of 38. Does that make sense?
Much more sense.
Okay. Yeah, I was answering a different question, but yes.
Well, are we done with that one?
Well, if he wants to do the whole thing, it's going to take up the whole
No,
class.
I'm good, that's all I need.
Okay. We didn't do the standard deviation, but you just follow the
The
formula.
rest I could do, I just couldn't get that
You couldn't get that one. Okay. Now, I want to ask Gentry, because you asked a really good question. We wanted it recorded. What was your question?
When do you use chi-square z and t?
Oh, yeah, that's what it
What
was.
do they mean?
Okay, we're going to stop sharing on this because we're going to write that on the board. So how do you decide when to use the z distribution, the t distribution, and the chi-square distribution? Okay? How do you decide that? Okay, so I'm going to give you the answer to that. To be honest, let me just tell you something. Next week, I'm going to give you about a 2-page outline. Actually, somebody told me they memorized it. I was like, really? Wow, that's impressive. And it's going to go into way more detail than we're doing. For this test, I'm going to give you what you need for this test. So there's actually a lot more stuff here. Okay, so you'll use the z distribution if you're doing a proportion, such as p hat. Okay? Or you'll use the z distribution if it's a mean and you know the population standard deviation, sigma. Okay? You're going to use the t distribution if it's a mean, okay, and you don't know, I will box that, don't know population standard deviation, sigma. Okay? When you use the chi-squared, there's going to be other chi-squared tests, but the only one we know today is if you want a confidence interval for the population standard deviation sigma. Okay, so it's the key here is confidence interval. The key here is mean. This is also a mean, but either know or you don't know the population standard deviation. The z also works with the proportion. Oh, you know, they should throw a third one on there. I didn't throw the third one on there. Or the normal approximation of the binomial. There's another one you could do. So 1, 2, and 3. I'll have to add that one. I didn't tell my last class that one. Forgot. Okay? You good?
What are they telling us?
What are they telling you?
Or what is it? When it comes to our answer, what is it?
So, I mean, that's kind of a broad question. So, but the idea here, what I'm trying to focus you on is you're trying to find either a confidence interval for a mean or a probability, for a mean. So mean, this one's standard deviation. Confidence interval for standard deviation. So those are kind of the key things here. Now, let me just mention here really quickly, I know we're out of time, and I want to answer Russell's question before we leave. And by the way, I posted my other lecture already. We had a little bit, you guys asked all your questions before we were recording, they asked them after. So they have a lot more information, so you might want to watch that. Next week, we're going to be doing hypothesis testing. That's when the class gets hard. Not to scare you, but just realize you're probably going to have to put more effort in studying. But we're going to go, the confidence intervals and hypothesis tests have basically the same requirements. So we're going to hit this stuff, when to use the t, the z, the chi-square, and also the f distribution. Okay, we haven't learned that one yet, but we're going to, okay? So we're going to hit that hard from now on. Like, that's the rest of the class is hypothesis tests. Now, let me answer Russell's question. I'll let you guys go.
So I just had a question on quiz 8.1.
You can't record that one anyway.
What was that?
Here, I'll stop recording because it's a quiz question, but yeah, you can just come out and ask. All right, so if you take the test today in the testing center, it's free. If you go tomorrow, it'll cost you money. The written test is tomorrow in class.
Will you post this tonight?
Yeah, I've already posted the other one, but I'll try to post this one.